Welcome to this explainer. I am so glad you're joining us today. We're about to take a super fascinating journey into the invisible plumbing that powers our entire modern world. You know, we click, we swipe, we buy, we stream, and we usually don't give a second thought to how it all actually happens. But behind every single digital transaction is an incredibly robust, deeply layered infrastructure. So let's dive right in and explore the digital age from the ground up. Think back to the start of the pandemic. Practically overnight, the entire world just packed up and went home, right? Offices, schools, our social lives, they all instantly shifted online. Bandwidth usage absolutely skyrocketed, and yet the internet didn't break. How is that even possible? Well, hooking onto that question is going to guide our entire explainer today, because the answer lies in the brilliant, resilient architecture of the network we rely on every single day. To really understand this, we're going to take a building blocks approach. Number 1, origins of the internet. 2, core internet technology concepts. 3, the cloud computing revolution. 4, how the web works. And finally, number 5, the mobile e-commerce platform. Let's start laying that foundation. Section 1, origins of the internet. We have to go back in time a bit here. The internet wasn't built in a day, and it certainly wasn't built for online shopping at first. Its evolution basically happened in 3 distinct epochs. It kicked off in the innovation phase back in 1961 with government researchers and the ARPANET. They were essentially just trying to find a way to share information without physically shipping magnetic tapes to each other. Then came the institutionalization phase, where massive entities like the Department of Defense and academic institutions stepped in to legitimize and fund the network. And finally, in 1995, we hit commercialization. That's when private corporations took over the backbone and expanded local service, giving birth to the digital economy we all know today. What's truly staggering is the sheer scale that commercialization unleashed. Wrap your head around this for a second. Back in 1992, there were exactly 10 websites. Not 10 million, 10. By 1996, when Google made its debut, there were 2 million. Today, we were looking at nearly 2 billion websites operating worldwide, and it's growing by about 500,000 every single day. That is an explosive scale, and it requires some serious heavy lifting technology behind the scenes to keep it running. Which brings us to Section 2, core internet technology concepts. How does this massive, global, multi-billion node network actually function without just collapsing under its own weight? The secret sauce really starts here, with packet switching. Instead of reserving a single dedicated line for a message, which is exactly how old telephone systems used to work, packet switching literally slices a digital message up into tiny little fragments, or packets. Each packet gets a destination address and is just sent off along whichever communication path happens to be available. They take totally different routes through various routers and are then reassembled perfectly at the destination. If one router goes down, no big deal. The packets just take another path. That is exactly why the internet didn't break during the pandemic. But you might be wondering, how do those packets know the rules of the road? That is where TCP/IP comes in. TCP, or Transmission Control Protocol, handles the actual slicing and reassembly of the packets, making sure absolutely nothing gets lost. IP, or Internet Protocol, handles the addressing and the delivery. This whole architecture operates across 4 distinct layers: the network interface layer, the internet layer, the transport layer, and the application layer. It's a standardized suite of rules that every single device on the network agrees to follow. So the crucial point here is that every device needs an IP address. For a really long time, we used IPv4, which was a 32-bit system that could handle about 4 billion unique addresses. But thanks to smartphones, smart TVs, and the whole Internet of Things, 4 billion was suddenly nowhere near enough. So the entire infrastructure had to upgrade to IPv6, a 128-bit system that can handle up to 1 quadrillion addresses. That ensures we are not going to run out of digital real estate anytime soon. The final foundational concept we need to talk about is client-server computing. Before the personal computer, we relied on these massive, centralized mainframe computers. And if the mainframe went down, everything went down. Client-server computing totally changed the game by distributing that load. Your laptop or your smartphone is the client requesting access, and these powerful servers provide the files, applications, or web pages. It balances the processing load and makes the whole network incredibly resilient. Moving on to Section 3, the cloud computing revolution. If client-server computing distributed the load, well, the cloud took that load and moved it straight into the virtual stratosphere. The cloud basically breaks down into three main pillars. First, you have software as a service, or SaaS, like Salesforce, where you just use an app over the internet. Then you have platform as a service, or PaaS, like Oracle, which offers development tools. And finally, infrastructure as a service, IaaS, like Amazon Web Services, providing raw server and storage power. This revolution was a total game changer. It drastically lowered the cost of entry for businesses. You no longer need to buy expensive servers to start an e-commerce company. You just rent the computing power you need exactly when you need it. Now, companies generally have to choose between a public cloud, which is managed by giants like Amazon or Google and shared among many tenants, or a private cloud, which is operated exclusively for one organization for maximum security. However, most large businesses today actually use a hybrid model. This lets them gradually adopt the scalability and the cost benefits of the public cloud while keeping their most sensitive, mission-critical data totally locked down on their own private infrastructure. All right, Section 4, how the web works. We've built the physical network, and we've added the cloud. Now, let's look at the service that sits on top of all of this.
This is a distinction people get mixed up all the time. The internet and the web are not the same thing. The internet is the physical infrastructure, the fiber optic cables, the routers, the TCP/IP protocols. Think of it as the actual roads and highways. The World Wide Web, on the other hand, is an information service running on top of that infrastructure. The web is the shops, the billboards, and the destinations located along those roads. Oh, and fun fact, Tim Berners-Lee published the very first web page back in 1991.
And the web is built on its own specific set of fundamental tools. It uses hypertext and HTTP to connect documents via those clickable links we use every day. It relies on HTML to give a page its structure and CSS to give it its style. It uses URLs as specific addresses so your browser knows exactly where to go. And the whole thing operates on that client-server model we talked about earlier. Your web browser acts as the client requesting the HTML, and the web server delivers it directly to your screen. But with nearly 2 billion websites out there, how do you actually find what you're looking for? Search engines like Google have to literally index the entire web to make it searchable. It's this massive, continuously running operation to map the entire digital world. It works like this. First, automated software called Googlebots crawl from link to link, indexing trillions of pages. When you type in a search query, it's sent straight to Google servers. Almost instantly, their algorithms sift through that massive index, scoring matching pages using over 200 different variables, things like relevance, page rank, and even your location. Finally, the best results are packaged into short text summaries and delivered to your screen. And the craziest part? All of that happens in a fraction of a second. Finally, Section 5, the mobile e-commerce platform. Because the way we access this incredible web has fundamentally shifted. The shift is just staggering. Around 260 million people in the US alone now access the internet primarily via smartphones. When Steve Jobs launched the iPhone in 2007 and the App Store shortly after, it quite literally changed everything. The internet was no longer something tied to a desk in a computer lab. It was right there in the palm of your hand, available anytime, anywhere. But with that kind of global mobile reach comes an immense challenge when it comes to governance. The internet spans the globe, sure, but laws? They stop at national borders. Regulating this digital infrastructure means navigating completely different legal frameworks. For instance, the United States leans heavily toward freedom of expression, while nations like China maintain very strict censorship protocols over what content is even accessible within their borders. There is no single global entity that has the final say, which makes policing the internet an incredibly complex, ongoing negotiation. But despite those regulatory hurdles, the mobile revolution absolutely birthed the modern e-commerce era. As our source material perfectly states, the drivers of Web 2.0 were mobile technology that put the power of purchasing into the hands of consumers, and later platforms that launched mobile purchasing power globally. Apps didn't just change how we text or talk, they completely reimagined entire industries and essentially put a global mall right in our pockets. We've covered a ton of ground today, all the way from the ARPANET in the 1960s to the cloud computing and mobile platforms of today. You now know exactly how the digital plumbing of our world actually works. So I want to leave you with this. As new technologies like artificial intelligence, digital twins, and the metaverse begin to integrate into this exact same infrastructure, what will the next generation of the web look like? How will the invisible plumbing evolve next? Thank you so much for joining me for this explainer. Keep learning, and I'll catch you next time.